Hello again. We are continuing with the work package 4. We will design our pipeline according to the chosen profile in the work package 3. Can show in here. We choose the profile in the work package 3 and we get the elevation and the length data from the QGIS profiling tool. Actually, we import this data in a TXT file, and after that we import, first of all, actually before starting designing our pipeline in the AutoCAD, we need to import this data to the AutoCAD drawing sheet. And now we have some calculations. The designing water transmission line requires data from the preceding sections. Discharge of the demand, we found these in work package 1. Elevation difference and the horizontal difference, we found these by using work package 2 and the work package 3. First, we need to determine our pipe diameter. So discharge of the demand as found as in this value liter per day, and if we translate it to the cubic meter per second, we found that 0.519 cubic meter per second discharge of demand. So the upper limit for the velocity is given as the 1.8 meter per second. So by using the discharge of the demand and the Vmax, we can find the diameter as 0.606 meters. And according to the given commercially available pipe diameters, we will choose the diameter as 650 millimeters. Now we need to again calculate the new velocity for the pipe. Again, we are going to use the formula, and then we find the design velocity as 1.56 meter per second, and this is also lesser than our maximum velocity constraint. Okay, let's continue. So in the section we see that from the beginning we have a hill in here, and we couldn't transmit water by gravity, so we need a pumping system in here. So pumps are being used for transferring water from a lower elevation, in here like that, to the higher elevation. So before the calculations for the pumps, we need to calculate the hydraulic slope. The pipe material, we choose the pipe material as ductile iron because of it can resist to corrosion, it can resist to external loads. The flexibility is good for the ductile iron and the good ductility, so it can deform before the breaking. And the absolute roughness for this ductile iron is given as 2.6 times 10 power of minus 4. So kinematic viscosity for the water at the 20 centigrade degrees is given as like that, and by using these values we can find the friction coefficient by using the formula again, and the Reynolds number. Again, we are going to use a formula, and after we use these formulas, we can find the friction coefficient at 0.070. And after that, we can now calculate the hydraulic slope. We have the friction coefficient, we have the velocity, we have the diameter, so we found the hydraulic slope as 0.00324. So first pump, location of first pump is in the 0 meter. And after that, when we look at the section, we have another hill in here, and the energy of the our water cannot enough for the beyond this hill, so we need to design another pump in somewhere here. So in the second hill we have a pump in here, and we know the total location from here to here, and we can find the x as 10.56 meters. So uh, from here to here is 10.56 meters, and then we need to calculate the head loss due to the friction. Actually, there is an example calculation for the head loss. We have the hydraulic slope data in here, and head loss due to the friction is calculated as the hydraulic slope uh, times L, the length of the pipe in here, for example. So the first head loss due to the friction is calculated as the J times the L. In here we found as 0.978 meters. So our piezometric level, we start the piezometric level by using pump from 707 to the 750, and after that we have 0.978 meters the head loss, so P1 is equals to the 749.02 meters according to. And the second head loss, we have again the same hydraulic slope, and we have the length as from here to here, and we found the second head loss as 1.42 meters. And again, if we calculate the piezometric level, 750 minus 1.42 meters, and we continue to calculate all of the head loss calculations. In here there is an Excel file for the calculations as we did before, and we reach the piezometric elevation in here. So we draw the piezometric elevation in our AutoCAD file. And after calculating the head loss calculations, we're going to calculate the operating pressure calculations. We found the piezometric elevation data, and we know the ground elevation in here. And we know that the burial depth for the pipe, we took the 1.5 meters. I can show it in here, for example. We have 1.5 meters burial depth, so our top of the pipe starts in here, and we have 0.650 meters for the diameter, and our base level for the pipe starts in here. So this is the elevation and this is the pipe. We can determine the pipe base elevation according to the ground elevation minus burial depth minus the pipe diameter. So we found piezometric elevation, and the operating pressure is the uh, piezometer elevation minus pipe base elevation, and we can find all operating pressure values in here. And the another parameter is the pipe slope. So for example, we can determine the pipe slope in this section. So let's use the slope function. Here. And there's a 1.96% increasing pipe slope in this section we have. And also, for the some reasons, we're gonna need to add some walls. For example, we need to add the air relief wall because we know that in the pipe system there is not only the water, also we have some air. So much air causes, for example, the reducing the flow efficiency. So we need to remove this trap air. So we are gonna need to put the air relief walls. And also we have the blow-off valves. They are used to release the excess pressure in a pipeline system. And high pressure means that they can damage the pipe. So we are also gonna put the blow-off valves too. So we are gonna put the air relief valves at the high points because air is likely to accumulate in the high points. So we are gonna put it, for example, in here, here, and here. And we have some blow-off valves, for example, here, and in here. So I just want to talk about the latex beamer as what I did very shortly. For example, I use the Madrid theme. I can set as default too. Oh, there's an error. Okay, let's do that again. So it didn't accept. Okay, for example, we can use the default, but I choose to use the Madrid. Okay, again, problem. Okay, in the beginning, in here, the title, the subtitle, author, date, and the beamer font again. I choose 1412, 1412. And begin for the document, open a frame in here, and I add table of contents. Let's continue with sections. And in here we have a work package 1, population calculation and the estimation of water demands. In here there is figures and the caption for all of the figures, and continue it like that. And I have the YouTube links below the every work package. You can reach the YouTube link by using the in here. And I will add also the work package for, and if I did something on the appendix, I will add this too.